Hi, now I would like to explain the suvat equation. In suvat equation, the S denotes displacement, U denotes initial velocity, V denotes final velocity, A is an acceleration and T is a time. Look at the picture. Now the car is being at rest. So this will be rest at for a long time. So from the graph we will be able to understand that the displacement time graph will denote us how the car will be at rest. Look at the next diagram. So here the car starts to move. So here the graph. At the first second it is at 2 meter. Second 4 meter. Vice versa like that. So its initial velocity is 0 and its final velocity will be 2 meter per second. So its velocity will be 2 meter per second. Now look at another equation here. Now I am going to explain the difference between the total distance travel and the displacement. So here there is a displacement. Here the displacement is in the forward motion. So the total distance travel will be S. Now look at the second diagram. So here there is a displacement in the forward. Now it will come back to another one position. Again it is moving on the forward. So here you can easily find the difference between this one and this one. So now I can understand the displacement always less than total distance travel. Right. Now we all know that the velocity is nothing but the displacement by time. So we used to denote V is equal to S by T. So S is equal to V into T. For an uniform accelerated motion, V is equal to average velocity, that is U plus V by 2. In the beginning I told you U is an initial velocity and V is a final velocity. So S is equal to average velocity into time according to this equation. And once again the acceleration is the change in velocity divided by the time. So here what is the change in velocity? Final velocity minus initial velocity divided by the time. So now I am going to derive the first equation of motion. So now acceleration is change in velocity by time. Here the change in velocity is V minus U by time. I will write V minus U is equal to A into T. And now I will take this U that side. Its sign will become change. So V is equal to U plus AT. Now look at the second equation. Now I am going to derive the second equation. Actually second equation is S is equal to UT plus half AT square. I know that S is nothing but the average velocity into time. Average velocity we already derived. Initial velocity plus final velocity divided by time. 2 into the time. From the first equation I am going to derive the value of V. So U, instead of V I am going to substitute U plus AT into T divided by 2. So U plus U, I will get 2U and the T has to multiply. So 2UT plus A, T into T squared, the whole by 2. Now I will cut 2 and 1 by 2. So S is equal to UT plus half AT square. Now the third equations of motion. Once again I am going to use the same. The displacement is equal to average velocity into time. Average velocity, once again I am going to use the same. Initial velocity plus final velocity by 2. And the time, in order to get the time, I will get the first equations of motion. That is A is equal to V minus U by T. So T is equal to V minus U by A. So here I am going to use the strategy, the mathematical formula. A plus B into A minus B is equal to A square minus B square. So I will get U plus V by 2 into v minus u by a. So this v plus u and v minus u, I will take a plus b in this form. So I will get v square minus u square by 2a. So finally 2a is equal to v square minus u square. Thank you.